Hi, this is Brian Cleaver again. So first we're going to take our styrofoam block and we're going to put cushions on both sides for reasons which you'll find out in a minute. 4 corners cushions. On the exact opposite side, we're going to put these 4 cushions on that side. Let's get it done. And just like that, we have cushions on this side, and on the opposite side, cushions as well. For the next step, we're going to drill holes into all 4 cushions leading to the other side with all 4 clip holders. So as you can see, we have 4 cushions at the bottom and 4 cushions at the top with lines with holes that line up between them. Okay, so we're currently fishing a line through the holes of the cushions. So right now we're drilling the 4 holes, sending 4 wires through each hole. So we just went and took all 4 cushions, having a wire that goes from there to up to here, and then 16 feet from each hole going up to the ring, which we'll do now. So right now we have our styrofoam cube connected in all 4 corners, connected 16 feet over to my dad, who is working on attaching it to a ring, all lines to a ring for stability purposes. So we successfully sent the fish lines from this cushion to this cushion, which follows all the way through to a ring over here. And then I'll show you what comes next. So the next thing we're going to do is create a device. This device will allow the payload to disconnect from the weather balloon when it finally reaches 21 miles into the atmosphere and pops. So my dad's going to go ahead and drill a hole. All right, so there's a hole. There's going to be a metal dropper in there, a piece of metal that goes out through the hole that was just drilled. And then from this part, it's going to be a line coming out of that hole you just drilled now. It'll be easier to show you guys how it works and stuff like that, which I'll do later on. All right, so next my dad is going to go ahead and create a incision on half of what we're calling half the device. Okay. That's it?
Yep.
Is that going to be wide enough?
Yep.
Hi guys, so the way this works is a string that leads to the weather balloon, comes down and leads to the bottom of the device, which is this plastic thing, and comes down and connects to this sinker for fishing. Once the balloon pops, the device falls and the string goes through the hole and disconnects, and the balloon disconnects. So that's how it works, and that's all. Displayed is a diagram of the weather balloon that me and my father Don created. On the bottom, it's featuring a styrofoam cube with 4 lines going through it in all 4 corners for stability reasons, and attached to it an iPhone. The wires then lead up to a ring for stability purposes. The ring then leads to the parachute. A disc is underneath the parachute, which connects to a fishing line wire that attached to the device. When the balloon pops, the device disconnects the weather balloon from the parachute. It then leads to a ring around the weather balloon, followed by the balloon. Displayed is the projected pathway and projected landing site that the weather balloon would take. Displayed is the actual pathway that the weather balloon took, launching from Abate Park, New Jersey to Manasquan, New Jersey. The following is needed for the weather balloon project: a 1 foot by 1 foot by 1 foot styrofoam block, 8 cushions referred to as discs, 57 feet of fishing wire rounded up to 60 feet, a piece of plumbing plastic that is round with only the bottom open, a fishing sinker, which is a metal object that is within the device, a ring for the cube and parachute to connect to for stability purposes, an iPhone. An iPhone 8 can be purchased online for $100 via the link mentioned. Get an iPhone case and a screen protector, a weather balloon at the link provided. Get a helium manufacturer. In New Jersey, I use Helium Plus East Inc. Their prices are decent. Call them at 973-742-7300. Get 250 cubic feet of helium. Get 3 zip ties to tie up the nozzle/neck of the balloon. Use duct tape to tie it as well. Take your SIM card from your regular phone and put it into the payload iPhone. Share this payload iPhone GPS location in the Find My app with another phone so that it can be recovered. The following is how to carry out preparations for a weather balloon. Open Google Earth. For maps, set up GPS coordinates as decimals by clicking Google Earth Pro in the top left corner. Then hit Preferences, then under Show Lat/Long, click Decimal Degrees. Select the area you would like to launch from. Then type in parks in order to find a good launch site. Put the pointer over the selected site. Record the latitude and longitude coordinates from the bottom right hand of the screen. The winds in the stratosphere are turbulent and hard to predict. Fortunately, the National Weather Service launches weather balloons to track winds. This gives us an estimate. Open SonHub at the link provided. For ascent rate, the balloon is 5 meters per second, as is the ascent rate for this weather balloon. Enter in the latitude and longitude. Then click Run Prediction. If it lands in an acceptable area, give or take a few miles, you are ready to go. If it does not land in an acceptable area, move the selected launch site. You will also see an estimate on how much time the trip will take in the upper right hand side of the screen. When you're ready to launch, visit skyvector.com. Any red circles in your launch path means you cannot fly there. Make sure you check daily. Even on launch day, make sure there are no red circles. Stay 5 miles away from all airports. So displayed on the screen is the math that I did in order to understand and predict certain events. Let's take a look. The stratosphere is between 7.5 miles to 31 miles. This weather balloon goes 21 miles high. Planes have the maximum height of 7.95 miles. The International Space Station has an altitude of 254 miles. The range of this weather balloon in the stratosphere is 7.5 miles to 21 miles. It goes at 5 miles per second, which is 11.18 miles per hour. This is the rate of launch for this particular weather balloon. Visit sunhub.org/calc I entered in 570 grams for the payload. Mass. Burst happens after 111 minutes, equals 1.85 hours, which equals 1 hour and 51 minutes. 11.18 miles divided by an hour is 1.85 hours, which is approximately 21 miles high when bursting. The stratosphere. We're going to calculate how much time it takes for it to enter the stratosphere and how much time it takes for it to exit the stratosphere. So, entering the stratosphere is at 7.5 miles divided by an hour times 1 hour divided by 60 minutes equals 0.125 hours equals 7 minutes and 30 seconds. So 7 minutes and 30 seconds is when it enters the stratosphere. When it pops and exits the stratosphere, it happens after 21 minutes. So 21 miles divided by 1 hour times 1 hour divided by 60 minutes equals 0.35 hours equals 21 minutes. The weather balloon enters the stratosphere at 7.5 miles after 7 minutes and 30 seconds. The weather balloon leaves the stratosphere after the balloon pops after 21 miles after 21 minutes. Due to turbulent wind in the stratosphere, the maximum length of time for the weather balloon to land is 2 hours and 46 minutes. Next is the Empire State Building. The height of the Empire State Building is 1,454 feet, which equals 0.28 miles. 0.28 miles times 1 hour divided by 11.18 miles equals 0.025 hours, which equals 1 minute and 30 seconds. It'll take 1 minute and 30 seconds for the weather balloon to reach the top of the Empire State Building at 1,454 feet. One last concept. Cell phone range. Cell phone reception ends at 3 miles high. The ascent rate is 11.18 miles per hour. So 3 miles times 1 hour divided by 11.18 miles equals 0.268 hours equals 16 minutes. Cell phone reception ends at 16 minutes after launch. The whole trip takes 2 hours and 46 minutes minus 16 minutes. Cell phone reception will be stored after 2 hours and 30 minutes. That's all.